dive in. Sample problems. So I'm grabbing this first sample problem from number 3, example 3, on page 299. I'm condensing it a little bit. So this is the formula we're going to use. They tell us the population, I can't remember if it's a city but the population, let's just say city, is 4.6 million in 2010. So what does that tell us? It tells us that this right here is 4.6 million. Now we got it, because we put 4.6 in there, we didn't write 4, comma, 600,000, comma, we didn't do that. 4,600,000. We got to know that this is in terms of millions, okay? In 2010, now that's something I'm going to use. Let's hit pause on that a second. It grew, so that means we're going to keep the plus, at a rate, there's my R, of 1.3%. Uh-oh, this takes us back to elementary school. You can't put 1.3% in for R. We got to turn that into a number, so we got to move the decimals back 2 places. So that's what we're going to put right here. So 0.013. Well, let's keep reading. It says it grew at a rate of 1.3% for 4 years. What's that? That's going to be our time. So it says, what's the function? The function that represents that is that right there. Now, they might clean that up a little bit and go 4.6, 1.013, and 4. They're just going to add those together, little PEMDAS. So that's the function. They didn't ask us to actually calculate anything, so we could be done. Then they want us to be a little bit more specific. It said, what will the population be? So they're saying, okay, use that formula. We know it started with 4.6 million. We know that the rate, because they say, what will the population be in 2040? If you read it, it says if the rate remains the same. So we're going to steal this 1.013. Says in 2040, this is where we're going to use this piece of information. How many years is that? Well, that's 30. So now, if you're going to do that without a calculator, good luck. So that's where you're going to have to go 1.013, hit that little caret symbol on your calculator, then type in 30, figure out what that is, and then multiply it by 4.6. I have it written down, comes out to 6.78. Now translate that information. You're not going to have 6.78 people, you're going to have 6.78 million people. So there you go. That's how you use this formula to actually calculate some information. It's good stuff. A couple more examples. Here we go. This one's about a car. Example 4, page 300. They just tell you, hey, there's a car, it's worth $24,000. Well, it's not worth, that's what you paid for it as a new car. And they just give you the function that describes its value in thousands. Now, how do you know that? Well, the 24,000, that's not, they put a 24 there. You could put a 24,000 there, but they don't. So they just put the 24 there, and then they remember that's in terms of thousands. So X years after the purchase. Now, you should know that cars do not increase in value. As soon as you turn that key on and drive it off the lot, it's already dropped about $3,000 to $4,000 worth its value, okay? So we know already it's going to be decay. But let's talk about it. Growth or decay? Well, I already told you it's decay. You know it's decay, but why? Because this is my B. Remember, if B is less than 1, that's a fraction or a decimal less than 1. It's going to be decay. That's the math explanation. Now, what does this say? What is the rate of decay? Well, remember, from our formula, I should have put this up here, sorry. 1 plus R to the T. This is going to indicate what our rate is. It's either increase or decrease. We know it's decrease. So notice this right here equals this right here. So I'm going to go, my rate is equal to 0.8. Notice, we're going to go minus 1, minus 1. So my rate is equal to negative 0.2. So that is my rate of decay there. Now letter C asks us to graph it. Now let's talk about that. Are you really going to plug in a whole bunch of numbers for x, like -4, -3, -2, -1, 0, 1? No, 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 no. We're not going to do that. Too difficult. We're going to go to decimals. And so what I'm going to do is give you a very inaccurate version of decimals, but if you type that in there, 24 times 0.08, and hit the caret, put in x, you'll get the graph, and then you'll be able to kind of read it. But I'm going to show you what I'm talking about here in a second. Let me pause this. All right, here's the equation right there. And it says graph it. There's a very wonky version of what decimals is going to give you, but I'm going to break down the parts. Notice this point is x is 0. That means I just bought it. I haven't even driven it off the lot yet. The car's value is 24. It's not $24. It's in thousands, so that represents 24,000. Notice my y-axis is the value of the car. And you can see it's going down as time goes by. X is in terms of years. And it says, when will the car be worth about 5,000? So what we're looking for is, where does y equal 5? Because remember, this is in terms of thousands. So if you just kind of looked at your graph, and they say, when will it be worth 5,000? We're looking for where here this value is 5. And if we went straight across, this drawing's not good at all. So I'm going to fix a little bit. It should actually be like this. And you would notice 1, 2, 3, 4, 5, 6, 7. We go up 5. So there's the value of the car. But it would take approximately 7 years if you look along the right-hand portion of your decimals graph for it to be 5 above. So we're looking for that spot to match our 5, which represents $5,000. Interesting problem. One more. Inner nerd alert. Inner nerd alert. I'm going to get excited about this problem. It's fun. It's fun to see where math actually applies, and it kind of makes sense. When am I ever going to need this in life? Well, here's a life application sort of a problem. Here we go. So this problem's presented to you kind of uniquely. They give you, and this is from example 5 from page 201. You can look at it. They got more pictures and everything, so you can kind of lock into what they're talking about. But they give you this graph of the value of a painting. So this person painted it, and they finished the painting job. So x is 0, so that's 0 years, 0 seconds. It's like they just finished the last little bit of paint, okay? And the value is 40. Now, I don't know if that represents thousands or millions or just dollars, but that's besides the point. Over 5 years, the value of that painting is 64.4, whatever, thousands. It'd be a heck of a painting, but let's just say, okay? So that's kind of a picture there. And then they give us this. They give us a sculpture. They don't give us a picture. They give us an equation. So they're asking you, after 5 years, see, they already give you that, like, so you go out 5 years, and then the value is 64.4. They want you to create that same situation here, because we have to answer this question: which item is increasing more quickly? Well, we take this and just do what we do. And we know that if x equals 0, remember we make these little charts for these things, and 0, put a 0 in there, anything to the 0 power is 1, so 1 times 50 is 50. So that's the sculpture was worth 50, whatever, 1,000 or dollars. So we got to figure out when x is 5, so after 5 years, how high, what's the y value? Well, we're going to put a 5 in right here, so let's go ahead and do that. 5. All right, let me get my calculator out. Okay, I found the value. It is, well, let me make, it's 5, 71.78. So that's how much the sculpture's worth after 5 years. Now some of you are going to say, well, it's the sculpture that's increasing more quickly. No, you're just looking at the value. The question is, what is climbing, what has a higher rate, here it comes, of change? See, they don't really say that to you, but that's what we need to calculate, and all of a sudden, stuff we've been learning is going to be applied. So now, believe it or not, we're going to go x1, y1, we're going to go x2, y2, and this is going to determine the rate of change. Remember, it's y2 minus y1 all over x2 minus x1. We're going to do that for both of them. So y2 is 71.78 minus 50 over x2, which is 5, minus x1, which is 0. So this would be 21.78 over 5. Let me get my calculator out. The rate of change, 4.356. Now we're going to do the same thing here. So there's x1, y1. There's x2, y2. We're going to plug it back into this formula. I think I got some space over here. So y2 is 64.4 minus 40. That's y1. x2 is 5, and x1 is 0. So we get 24.4 over 5. And, I mean, you can use some common sense. This is going to be a bigger number than this. This 24.4 over 5 is going to be bigger than this. So you can calculate this, but this is going to be bigger. Now, if they ask you exactly what the rate of change is, you'd have to figure this out. But they asked us which one's increasing more quickly. That'd be the painting, okay? Fascinating stuff. All right, good luck on your homework, you guys.